Remember, the data that you're trying to get the variance for could be population data or sample data. In the case of population, here is a formula as before. In the case of a sample, this is a small change happening, which is you're dividing by n minus 1 instead of n. The reason for that, researchers found that when you divide by n minus 1, the value here will be bigger a little bit for the sample, which will make it closer to the actual value of the population. Anyway, for us, we need to know that the only difference is that instead of dividing by n for population, we're dividing by n minus 1. Remember, the n on the numerator up there is still the same, and it did not change. Only the lower n has changed, it became n minus 1. The symbols also have changed, so from sigma square for population, it became s square for the sample. You probably noticed also that n small for sample data size instead of n capital for population data size. So these are the small changes that happened in the case if the data is sample data. Let us see an example to tell if you are able to find the difference between the sample variance and population variance from the question. So let's read the question and try to find out if this is sample data or population data. Christine is currently taking college astronomy. The instructor often gives quizzes. So the instructor gives a lot of quizzes, not just like in our case we just have 2 quizzes. He actually gives a lot of quizzes. On the past 7 quizzes, Christine got the following scores: 1, 2, 3, 4, 5, 6, 7 scores in 7 quizzes. Are these all the quizzes? This is a question that you have to ask. Are these all the quizzes the instructor gives, or these are just some of them? In fact, they say on the past 7 quizzes. This is the last few quizzes, or last 7 quizzes. So that means what? That means there were actually more quizzes than the 7. So this is just a sample. This is not the population. So if he tell you here, find the variance, and he doesn't specify, is it the population's variance or sample variance, he's expecting you to find out yourself from the question. You need to understand the question. You need to know the nature of the data. The data here are sample data, and thus you have to find the sample variance. Remember, you'll be dividing by n minus 1 at the end. So let us start calculating. Remember, you mainly need sigma x and sigma x squared. So all I need here really is going to be sigma x, and of course I need to get sigma x all square, okay, and then I need to get sigma x square. So I'll do that just by the calculator quickly and see what we can get. So let's get sigma x first. 50 plus 12 plus 38 plus 25 plus 16 plus 48 plus 58. This is equal to 247. Okay, great. So that means here I have to write 247. Now this will be the square of this amount, which will be 247 square. I mean, you square this amount, how much you're gonna get? Okay. So if you square this amount, just put it here square. So it gets 61,009. Okay. So that is 6. Oops, that doesn't look good. Okay. 61,009. And now I need to get sigma x squared. So I need to square every value before I get the sum. So let's start all over again. Now this 50 square plus 12 square plus 38 square plus 25 square plus 16 square plus 48 square plus 58 square equal. So that's 10,637. Okay, so let's write that here. It's going to be 10637. Okay, so I now got sigma x and sigma x squared. Now it's time to put them into the formula. So in this case, remember, this is going to be a sample variance, sample, right? So in this case, the formula will be what? Will be s squared equal to sigma x squared minus sigma x all square divided by n, and then I divide by n minus 1. So in this case, sigma x squared will be 10637 minus sigma x is all square, which is going to be 61009, and then I divide this by n, which is the data size, which is 7, and then I divide this all by n minus 1, which is going to be 6. 7 minus 1 is 6. Okay, when you do that, remember, when you subtract this minus a quantity that's a fraction, you need to get the fraction first. So you need to prepare the fraction first. So 61009, when you divide it by 7, you get 8,700 something. Yes, that's good. We do that because I want to make sure that this number is going to be smaller than this one. 8,000 is smaller than 10,000. So when you subtract them, the result will be positive, and that's important. Otherwise, you probably made a mistake, because the answer can never be negative, and the answer must be always positive for the variance. So in this case, I can subtract 10637. Okay, of course the answer here need to be reverse assigned because I need to put this first. But anyway, I got the answer, which is positive, and now I need to divide this answer by 6. So I divide by 6, and then this will give me a final answer, 320.24, something like that. So that's going to be 320 point, we can approximately say 0.2. Okay, so that's the variance in the case of sample. So that is S squared sample variance.